I get it why he thinks I'm 90. All right, here we go. Let's do this. So we're going to take what we have learned, and we're not going to change it at all. We're just going to rename it. Okay? I'm trying to think. You guys all remember, like, you remember the music artist Prince? Prince? Everybody remember? You've heard of him? He was a big. He's one of the. I wouldn't put him quite on the Mount Rushmore of music artists of all the times, but he's up there. Okay, and so he went through this phase where he renamed himself, and then he became the artist formerly known as Prince. And instead of going by Prince, he went by some like symbol. It was this funky like 5 with a circle and an arrow and all. It was cray. Okay. But that's what we're going to do. We're going to rename rate of change. Okay? Because rate of change also means something when we're dealing with a line. Okay? And so what we're going to rename it as is slope. Okay? So rate of change is now slope. Okay? So that's what this means right here. When we say slope, aka rate of change, slope is also known as the rate of change. Okay? Now, slope is going to be the steepness of a line. The bigger the slope, the steeper the line. Okay? So it tells you which way your line is going. Okay? Okay? So that's what slope is. Okay? They are all a number that describes the rate something is changing. So up to this morning, what did we call rate of change? Or what was our description for rate of change? Delta y blank delta x. Give me one of 2 words again. Divide works or over. Yep, or over. Okay? All right? So we had rate of change as delta y over delta x, right? Which was the change in the y divided by the change in the x. Yeah? Just got to take a peek, see when we get to it. Perfect. Okay? So, what we're going to say now on a graph, and these numbers or these words are going to be ingrained in your brain. Now we're going to say for slope, which is the same thing as rate of change, which is the same thing as delta y over delta x, which is the same thing as change in y over change in x. We're going to say rise over run. Okay? Rise over run. So if we're looking at a line, we pick one point. We put our finger on one point. And then we go, how much do we go up or down? That's our rise. Divided by how much we go left and right. That's our run. Okay? Rise over run. Okay? That's what you need to be thinking. Slope is rise over run. Rise over run. Rise over run. Okay? Okay? So, how did we find the rate of change before? We found this difference, right? Right? We found that difference. Okay. Alright? So we found the difference between those. So we went B minus D. Or we went D minus B. It doesn't matter. Right? Okay? And then on this side, we went A minus C. Or we went C minus A. Right? So the rise over the run, or the change in the y's over change in the x's, the slope, if you will, is going to be B minus D all over A minus C, or if we went the other way, if we had a graph, I'm going to leave it dashed. If we had a graph and all of those were points on it, okay? That's why I went with a dashed graph here. If we had a graph, we could pick any point and then find another point that's also on the line. And our rise would be here. And our run would be there. Or our run could be there. And our rise would be there. And then our slope is rise over run. Give you a moment to get that written down. So now, okay. So now tell me we're going to say what the rise is and what the run is. Okay? So we're going to, for each question here, we're going to say the amount of rise is how much and the amount of run is how much. Okay? So in the first one, what would the amount of rise be? No. Will? 2, because remember it's rise over run. So the amount of rise would be 2. The amount of run then would be 5, because that's on the bottom, right? Okay. Ooh, what about number 2? So we could write it as negative 2 over 1? Yes, we could. If we write it as negative 2 over positive 1, then tell me what my rise is. My rise would be negative 2. What would my run be then? Okay. We're going to keep it like that. We're not going to say that it could also be a rise of positive 2 and a run of negative 1. Okay? We're going to keep our negatives in our rises for right now. Okay? All right? With that being said, you do the next 4. Okay? Find the rise and the run for each of those 4. Go. Did we all get a rise of 2 in the first one and a run of 3 in number 3? In number 4, did we get a rise of negative 4 and a run of 3? In number 6, did we all get a rise of -7 and a run of 1? Okay. How many people in number 5 now? How many people put a rise of 1.5 and a run of 1? Okay, is that legal? Yeah, 100% that's legal. 100% that's legal. This also, if you wanted to get all fancy schmancy, this is also a fraction that's equal to 2. Or excuse me, it's equal to 3 over 2. Okay? So we could have also have said that a rise of 3 and a run of 2. And those are the same. Here's why. We'll deal with green first. How do I go with multiplication from 1 to 2? With multiplication. Not with adding, so don't tell me plus 1. Multiply 1 times 2 and I get 2, right? Okay. What is 1.5 times 2? It's 3. So see how this one right here went times 2, and then this one right here went times 2. So those would be the same slopes because they're just multiplications. Okay? All right, let's get into it. So now, in math, there are 4 different types of slopes. Okay? We're only going to deal with 2 of them today. Okay? The other 2 we'll get to a little bit later on. Okay? So there's positive slopes. There's negative slopes. Those are the 2 we're going to deal with today. There's zero slopes, so you don't rise, but you run. What do we call that? If we don't rise at all, but we just run. Anybody remember what? Horizontal. That's our horizontal slope. Okay? And then we have undefined slopes, where we rise, but we don't run at all. And those are vertical. And the reason that those are undefined slopes is because we're divided by 0. That just can't. Okay? Alright? So, a positive slope. Give me an example of a positive slope. Give me an example of one. Like a numerical example. One half is an example of one. 17 is an example of one. 28. Can I go 17 over 100? Okay? Those are all examples of positive slopes, right? Because they're all positive numbers. Okay? So now, remembering the fact that slope is rise over run. Okay? And let's use this last one as an example. 17 over 100. If I started with a point right down there, okay, and I had a slope, a rise over run of 17 over 100, how would I get to my next point? Gotta go up how many? 17, and then which way is over? To the right, 100? Okay, so that one would be like way over here, right? And then I could connect those 2 together. Like so. All positive slopes will go up and right If it is a positive slope, that line, as you look at it, is going to be going up and right all of the times. Up and right for all the positives. Give me an example of a negative slope. I'm going to go just with negative 125 is all I heard out of there. Okay, give me another one. Negative 1. Give me a fraction. Because the prize overrun. It's automatically a fraction. Yep. Automatically a fraction. And so on and so forth, right? Right? It should fall over. Okay? So if I have a point, I'm going to put my point there this time, and I have a negative slope of, we'll go with negative 1/5. Okay? What is my rise and what is my run on negative 1/5? Do we agree with a rise?
Negative 1.
So which way? So give me a direction. So down 1, right 5. We agree with down 1 and right 5. Okay? So my next point then would be down 1 and right 5. What direction do negative slope lines take? We got down and right? Because it doesn't go up and right, it goes down and to the right. Yeah. Oh yeah, let's get into it. So now we got two actual graphs. This is, Chloe, I hate to break it to you. This is no different than what we were doing last week Friday when we were walking around the room and we were picking up stuff off of a graph. This is no different than last week Thursday when we were looking for points off of a graph. This is no different than this week Monday when we were picking up points off of a graph. And this is no different than yesterday on one side of the sheet when you had the graphs. Okay? All the same, it's just instead of us saying now rate of change, now we're saying find the slope. Okay? One thing that I forgot to mention, by the way, the symbol for slope is M. Okay? The symbol for the slope is M. Okay? And it because it was a French mathematician that found this concept of slope. And in France, in the French language, the word to climb is monter. And that's the French verb for to climb, monter. And so this guy was walking around the hills of France in his village, and he's like, each of these hills has a different slope, a different pitch to it. And that's how he came up with the concept. So that's why he used M way back in the, I don't even remember, I think it was the 1600s that he came up with the concept. So he used M and it stuck. Sometimes you throw stuff against the wall and it sticks. Okay? Okay? So we got to find 2 points that this line goes through. What do you got, Bryce? Give me a 1 point that this line goes through. 3, 2. That's 1, 2, 3, 1, 2. That's that point right there. I would agree that it does not go through that point. Okay? -2, -3. 1, 2, 1, 2, and 3. I would concur that this point goes through the point -2, -3. would you like to change your 3, 2 point? No, that's what you gave me. To 2, 3? Okay, let's check if 2, 3 goes through. Oh my gosh, it does. 2, 3. Right? Okay? So my rise is going to be here. How many did we rise? Well, let's count. 1, 2, 3, 4, 5, and 6. So we rose 6. Okay? Then my run is here. 1, 2, 3, and 4. So what would my slope be? 6 over 4, right? So my slope is going to be 6 over 4. Now my question to you, Dylan, is this. You get the hardest of the hard questions today. Do I, birthday boy, like that slope as is written? Why not? Why don't I like it? See, I told you it's going to be the hardest question of the day. No, I don't mind it because it's got to be in fraction form. Okay, we are not doing mixed numbers on this stuff. Slope is in fraction form. You can reduce it. Chloe, what can I reduce it by? 2. Both can be divided by 2 because they're both even, right? Okay. So if I divide this by 2, and I divide this by 2, 6 divided by 2 is 3. 4 divided by 2 is 2. So I like 3 halves a whole lot more than 6 fourths. Okay. On this of the all of the times day, on the Valentine's Day, you like your significant other when they give you a gift, not when they don't. Okay? The gift is a fraction. Okay? Try number 9 right now. Try number 9. Find me the slope of that line of number 9. Got it already? Yes, you knew it. Somebody give me a point that this line goes through. -2, 2. Okay. Give me another point that this line goes through. 0, 2 is a 0. Okay. I went green for my rise. So my rise is here. How much did I rise? No. My rise is the green part right here. How much did I rise? Okay, I didn't rise, I went down. So how can I say down in terms of rise over run? Negative, negative, -1. So I only went down 1 space. Oh, okay. Gotcha. All right. Then I ran how many? 2. You would have run 4. Right? Okay. So this gives me a slope of -1/2. Okay. Now, if you chose different points, Ken, when you reduce your fraction, it had better reduce down to -1/2. Okay? But it doesn't matter which points you choose, but it will always reduce down to -1/2. Okay? Like yours, you went -2 and 4 as your rise and run, reduces to -1/2. Okay? Do we have to reduce our slopes, reduce our fractions? Yes. Yes, we do. to reduce our fractions. Okay? Table below shows how far a hiker is from his destination on a 20-mile trail. Calculate the rate of change. Okay, so that means I'm going to take 2 points and I'm going to figure out what it is. So you want to take top two, first and the third, first and the fourth, first and the fifth, or some other combination thereof. Which one do you want to take? Chloe, what do you want? First two? Okay. So what is my change there? What is that change? To go from 20 to 15. Minus 5? Okay. What is this change right there? Plus 3. Okay. So what is the rate of change there? Negative 5 over 3 what? Because now, because it's rate of change, we got to have words. Negative 5 over 3 miles per hour. Okay. What is the meaning of that? That he's traveling a distance over some time, right? Right? Speed is always positive, right? Okay. You can never travel at negative 60 miles an hour. Okay. Why is this rate of change negative if it's a miles per hour, which is a speed? What is that telling us? Nope, he is moving. What is it telling us? He's doing 5 miles every 3 hours, right? Okay. So he's walking or he's hiking at a rate of 5 miles every 3 hours. Yes. But what does the negative part mean? You got to kind of go back to the description of what this is. Okay? This is a hiker is how far from his destination. So what does a negative rate of change mean for this one? Say it louder, Will. He's getting closer to his destination is what this is saying. Okay? Because the charts told us the distance he was from the object. Now, if the chart had told us the distance that he was walking, that would then be going up, and so then that would be a positive. Okay? All right? With me? Sweet. Let's do some homework.